Hello everybody, we are Alfredo Castro and Germán Hidrobo. We are team number 5 and we are gonna to present two new modules that will be really useful. Will be the module road and the module station. First, to attach these two modules to Arena, we need to go to File, to Template Panel, Attach, and we're going to the folder where you have Arena, that in my case is Bootcamp here, and Broker Software Arena, and here we have the templates. The templates that we need is Advanced Transfer, so you just need to find where you install Arena and you're gonna to add it. As I have it, I will not put it, and you will have this. This is the new module that we will need, the new template. So okay, in this case we are gonna to present a simulation of a restaurant. Here we are gonna to have a layout of 6 tables. This is table number 1, 2, 3, 4, 5, 6. The simulation will be really simple. We will explain you how to use these two new modules that these are basically used to simulate the behavior, the translation of the entities through a layout, so you can see it in a graphical way in 2D. So to build this, we are gonna to go step by step. Okay, so now we're gonna to start modeling our restaurant. First, for do the layout, the image, we need an image. You need to download it from Google. You can create your own image in Word, in Paint, wherever you want. So here we already have prepared our image, the layout of a restaurant in Paint. The only thing that you need to do is to the image that you already have, you give right click in it and you put copiar in Spanish. You go to Arena, you put right click again and you just put it paste. So here you just locate where you want your layout. Now to start building the project, the restaurant, the simulation, we start as we always do with a create. Here will be the customer's arrival. Our entity will be the customer, and for this simulation we will establish that will arrive an exponential distribution of 10 minutes. Then we will use our first new module that will be a station. The best way to describe a station is, imagine that your entity is in a point A. Which point will be this one? The entrance of the restaurant. We want that entity goes through all the layout and go to one table. So the station module allow you to take your entity to the point A to the point B. Yeah? We will see in a better way later when we have already our module, our simulation built. So now, in a restaurant, in a normal restaurant, you have a decision when the customers arrive. If the restaurant is empty, you stay and you order your food. If the restaurant is full, you just leave the restaurant. This is how we will do the simulation. I know that sometimes the people wait, but just for the case of the simulation, we are going to say that they will leave if the restaurant is full. So now that we have defined the station, that we know that we are going to take the entity to the point A to the point B, we need to establish a route. How this entity will go through the layout. For that we need route. So we need one route when they decide to stay in the restaurant, and one route when they decide to leave it. Yeah? So to explain a little bit better, I'm gonna to make the connections. Now that we have this, we're gonna to say in this decision, if the restaurant is empty, I stay. If the restaurant is full, I leave. So this route needs to go to another way. But if you see here is not like an attachment, it's because the routes, they take you to another point. And this point will be another station. So we are taking the customers for this station to this one. And this one will be connected to a dispose. Why? Because the entities will leave the system. Because the restaurant is full. So how we establish that? You just go to the route for. Here you can put it any name that you want. It's really important that you put a time to that route. You will see why later. But in this case, just to make it simple, we will say that they see like 10 seconds, oh it's full, I leave the system. So we will put it in 10 seconds. The destination type will be an station. Here you can put anything, a sequence, an attribute, an expression. In this time we are taking this route to another station. And the name of that station we see here is station 3. So we just click here and we go to station 3. And we just put it. So that means that the customers will arrive. They will stay in the point A that is defined by the station 2. They will decide if they stay in the restaurant or they leave. If they leave, they are gonna to take the route 4. This route 4 will take you to the station 3, that the station 3 is defined as the exit. So goes to and dispose. Okay, after that, we are gonna to simulate the order of the food. Yeah, that will be defined by the route 3. First, as we saw before, we need to take from this point to the point of making food. For do that, we need another station. So we are talking from station 2 to station 3 or station 2 to station 4. This will be defined by this decision. So in the station 4, we are gonna to have a process. This process will be the one that they will order the food. Here we have a resource that will be like taking the orders. Really doesn't matter. And we will have a triangular distribution, or just say 4, 5, and 6 minutes. Yeah. After that, we are gonna to need a decision. Why a decision? Because once you make an order, you need to decide in which table you are gonna to stay. So here just we will put the connection so you can see. So this decision, we are having 6 tables in our layout. Table 1, 2, 3, 4, 5, 6. So for all those decisions, we will need a decision and wait by condition that we will define it a little bit later. Okay, it's not letting me do that, so I will just put it cancel, just like you know what is next. But now, so from this decision, as we say, you are now here in the order, you are ordering your food. Then you take then you need to take the decision to which table you are going to go. So you need a route. You need a route to go to the station where you order your food, to the station that in this case is the table. So here we need 6 different routes. Sorry, it will take quite a few moments. So now we have here our 6 routes. for each table that we have. So the customer will take a decision to which table he's going, if it's empty, of course, and that will be decided here in this decision. So now that we have the route that they will follow to go to that table, they will arrive to a station. So you need another 6 stations that will represent the tables. So you need another 6 stations. No, here is not, has not a connection. So you put your 6 stations that I repeat, they are your tables. Yeah. So now that we have the destination from the point, the station 4 of taking food, to which table the customer is gonna to decide go, we need to establish a time that they will spend in that table. For do that, we will use a process to represent the time that they are gonna to stay in each table. So in this case, we are just gonna to put again 6 processes that represent the 6 tables. After that, after this process, okay, we are gonna here to define, like, we're gonna to add the resource that will be table 1, if you want to put it like that. Here also will be established as table 1. We will just give it like this distribution is fine. Of course in minutes, because if it's in hours, the simulation will take quite a lot. So we have here is the table 2. We also add a resource. Oh, here is just showing me that it's a mistake, so I can call the process like that. So I will keep putting the resources, these ones with the correct tables. So we can change this to process table 1, to process table 2. This one will be process table 3. That. This one will be process table 4. We need to add the resources here. That will be table 4. Yeah, it's taking quite a long time. Process table 5. Here we will add the resources, that is table 5. And the last one, process table 6, and we add the last resource that we need to create, like, you know, the waiting time. That in this case is the utilization of this resource. Always put it in minutes, I almost forget that. Always in minutes, because that's in what we are measuring our system. This one is already minutes, perfect. So now we are gonna to send these people that they were in this, that they were eating in the table. So they spend a certain time in that table, but after that they will go to the exit. So going to the table to that exit is going to a point A to a point B. What means that? That we need to establish that point B. How we do that? With another station. So we are gonna to send. We are gonna first. Okay, this station will be established as the exit. Yeah, but first we are gonna to declare which route they will take for going to this point. Yeah, all these tables are going to the same point, but they need to go through a route. So we're gonna to establish these routes. It's really clear that you understand that these routes are for visualize in a graphic way how the entities goes through the system to the point that we are establishing. So this route is going to the station 11, that is the exit. So this route also are going to the station 11, that is the exit. So we establish that in all of them. And that's it. So after they are going to the exit through these routes, they are going to this station 11. So after this station, the entities arrive to this station 11, we need a dispose to close the system. So we go to the basic process, dispose, and here the entities are leaving the system. So basically we have built our simulation. So we just need to connect everything with all the processes. Now that we have all the tables with that distribution of utilization, of course, if you are going to do this in the real way, each table behavior in different ways. And here we need to start doing our decisions of how the entities will behave in this system. So the first one that we are gonna to do is the decision if they see full the system or if they see empty, so they know if they need to go. So this will be two ways by condition. The condition will be an expression, and we are gonna to build that expression. So how they're gonna to stay in the system of leave depends if the system is full or if it's empty, right? So that means that we need to go to our process, and we're gonna to go to the number in process, the number that is already the entities that are in the tables in this case. So we give double click, and we are gonna to see if the table 1 is full. If the table 1 is full, they need to go to other table. So we just copy. No, we can do it one by one. So if the table 1 is full, they need to see the table 2. If the table 2 is also full, they're gonna to go to the table 3. If the table 3 is full, they're gonna to go to the table 4, and so on. Yeah, table 5, and the last one will be table 6. We put it OK. So we have our expression. If they see that everything is full, if this decision, they see that any of these tables are available, they are gonna to reject this expression and they are gonna to go to the false part of the decision that will take you to the station 3 and they will go to the dispose. How we see here is connected to the station 3. The station 3 is gonna to go here and they just leave the restaurant. Otherwise, if this condition, if they see that there is an empty table, they are gonna to go to the route to the station 2 to the station 4. So we need to put it out here. So they are gonna to go to the station 2, they decide to stay in the restaurant, they take this route that we are gonna to draw later, I will show you how, and they are gonna to go to the station 4. Now in the decision, once they are in the station 4, they are going to go to the process of ordering the food. Here we need another decisions. Why? Because they need to choose now to which table they are going. If they are going to table 1, to table 2, etc. And what depends this? If they are empty or they are full. So we need n way by chance. N way by conditions. We are gonna to create a condition. So we build an expression again. And will be exactly the same as the last decision. Here we will see the entities in process, the entities that are using that the resource. So we need to have to create to build our expression based in the numbering process. So we see if the table number 1 is empty, they stay. If not, they are going, we can copy this, they are going to the table number 2. How? We create this expression. Now we create the other one, but this one will be table number 2. If table number 2 is, and if table number 1 and table number 2, they are full, they are going to the table number 3. So we build that until all our tables are completely full. Exactly the last one. Yeah, so here we have all the decisions. If none of these decisions is accomplished, they need to go to dispose. They need to leave the restaurant. How? They can take the food with them, or they in some cases, of course, we know that they wait. But in purpose of this model, so you can see it a little bit easier, we are going to say that they just take the food to take away and they go to their homes. So we connect all these decisions to the routes that we established, that these are the routes that the customers will pick to go to the ordering food to the table that they decide to stay. If they are not gonna to stay there, we are gonna to send them to a dispose. Which dispose will be that? We already have one here that is in the station 3. So we are gonna to create a route, and this route will send them to the station 3, and the station 3 is the exit. Why? Because there was not an empty table. So this means in another way that they are taking the food away to his home, to their homes, or who knows. But here we're taking to the station 3, and I don't know if you remember, but at the beginning I told you that we need to be careful with this, with the road time, because if you live in 0, that means that there's not a route that they need to take. That means that the route is not significantly, so you don't need to really graphic these things. But usually if you go to order your food to the table, you take some time to go in there. So we need to establish this route time. In this case, we are gonna, for purpose of the model again, we are gonna to say that all the route times that we have will be of 10 seconds. Or 9, better 9 seconds, it really doesn't matter. So we just create 9 seconds. Remember, the units must be in seconds. Yeah, once we're done with this, we can say that our model is already done. Seconds. And the last 2. And perfect. Our model is already done. We have like everything that we wanted. So just to you see how it works again now totally, the customers arrive, they stay in the entrance, and they have the decision to stay in the restaurant or to leave. This depends if the restaurant is full or empty. If it's full, they are gonna to stay they are gonna to leave. So they go to the station 3 and they just leave the restaurant. If they see a table empty, they are gonna to the station 4 through the row 3. They are gonna to take this path. So they go to this station, they order the food, and they need to see now if there's a table empty, if nobody like in the waiting line of the ordering food already takes a table. So if they see that, if there's a table, they take any of these routes. Why? Because they will see which table is empty. If they see, for example, that table number 3 is available, they are gonna to take the route 7. The route 7 gonna to take them to the station 7. The station 7 is the process of the table 3. They eat through the distribution that we established. They stay in that table and they leave. They leave to where? To the station 11. Through what? Through the road 13 in this case. And they just leave the system. So that's our system. But what really gives a value and added value to this new two models, station and route, is to graphic that in a layout. So here we have our layout. We can make it a little bit bigger. So for that we need to use this menu that is here. This R here stands for route. As you see here, you have like different like modules to simulate different processes. For example, conveyors, starts, stops, etc. All these modules here are especially one to each module in the advanced transfer. So for the module route, we need to use this one here, the route. So this is how it works. This is how we will establish the path that they will use through the restaurant. So the first one, they are gonna to stay to the station 2. And we will send them from station 2, and we will say that, oh, they are gonna to leave the restaurant because it's full. So they are going to the station 3. So we are sending from station 2 to station 3. How we simulate that is easy. It's like drawing in your own layout. So you just click once and you have already one path that you can follow. So the client is here right now. It comes inside the restaurant and see that you click another for take another path. So in this point, he see that the restaurant is totally full. So he return again to the exit and he just leave the system. When you want to end this road, this path, you need to give double click. So you give double click and you have here your path that will follow the people that see that the restaurant is totally full. And that's how we are gonna to draw each path of this simulation. Now we are gonna to send them from station 2 to the station 4, that is ordering the food if they see that the restaurant is not full. How we do that? We go again to the option road, and we're gonna to say that they are going to station 2 to station 4. This is our station 4 and the entrance is the station 2. So if you see, if I just put the mouse there, it just showed that there's the point of the station 2. So you just give one click and you follow any path you want. I will follow the same I already draw. But this time I just go to this part here, I give another click, and I show that this is the station 4. This is the point of the station 4. So I give double click to finish the path. With this we are saying that they are going to the station 2 to the station 4. Now, once they order their food, they need to allocate to the different tables. How we are gonna to do that? Again, with root. Just that this time the customers already ordered their food, so that is station 4. The stations of each table is defined by these ones here, the ones that we establish. So that means that we need to send to the station 4 to the station 5, the station 4 to the station 6, the station 4 to the station 7. What means that? They order the food, they go to table 1. They order the food, they go to table 2. They order food, they go to table 3, and so on. So we go to our layout, and we say that this is station 4. Station 4 is our first table. This I define it as my first table. So how they are gonna to go there? So I say they come here, they take this path, and this path, and they go here. So I click double click, and this is my station 5 that represents my table 1. We do exactly the same for all the tables. Station 4, that is where they order the food. Now that they are going to the station 6, that is my second table. So I define that they will take this road to go there. And there is my second table. So do that to each one. They go here and then they just go to this table. Station 4. Now that we have all our routes established, we need to create a new route, as we saw here, that will take the customers that were in the table to the exit. That will be going the station 5 that represent the table 1 to the station 11 that represent the exit. So we need to create all those roads again that will take the customers that are in this point to the exit point. We go again to road, just that we are gonna now the station 5 that was our first table to the station 11 that is our exit. So we go, and be careful because you need to see this box around the station, and then you click there, so you take that station. The customer will take out of the table, will go through this path, and they will go to the exit. Here you need to create a new station that is station 11. If you click the station that we already have created here, this station is number 2. So that means that they are gonna to the station number 2 and going to another dispose, but we don't want that, because we need to see like how many people were eating in a restaurant and how many people leave a restaurant because it was empty, what was full. So we do that with each of our tables. The station number 6 to the 11. This is the 6. You draw the path here that the customer will go, and you put it in the station 11. That one. Yeah, to the station 11. Go through here. They follow like this path here, and they leave the system. This will be station number 8 to the station 11 again. This is the 8. Now we're gonna to say that we are gonna to live in this way. You can choose any way you want that your simulation looks fine or that you like it. Then is station number 9 to the station 11. This is station number 9. They're gonna to take this one here, and they just leave the system. And the final route is my station number 10, leaving the system through the station 11, that is this one here. And they are going through this path here, this path, this one, and they just leave the system. I think we already have everything done. So what we need to do, this is important, you click in the picture, you click the right thing, the right click, and you say bring send to back. So that means that you will be allowed to see like the simulation of the roads that the entities take. So once you have done that, we will run, and you will see one thing that is really important that you need to take in account. So just so you see, we will run for 3 hours. Yeah. I don't want that the speed goes too fast. I think that is fine. So we start. Okay, it's sending us an error. Road in station number 1. We find it. This goes to station 3. Oh, this goes to a station. Here we forget to send this road to the station 5. So we send all these ones to the stations that they belong. Yeah, otherwise will happen what we saw, because they were sending to station number 1, but we have not defined that station number 1. So yeah, now that we have done that, perfect. Everything is in minutes. Perfect. Okay, so let's simulate now. Okay, so now that we simulate, and we saw that the model is, the simulation is doing fine, but here, when they go through the roads, we can see them really visually. So one theory that we think will solve this is if we increase the distribution between them. So we're gonna now to use hours instead of minutes as we have before. So if we change this, also the hours, if we change this, we will be able to see a better and not so fast behavior of the entities in the system. So the last modifications that we did, just to summarize, is these ones we put to the stations that they belong. We increase the distributions, and I think that was all. We just check that everything is correct now. So now we assume that we will be able to see a little bit better. Okay, as we saw, changing those distributions is still making is too fast, the simulation through the paths. So one thing that we see here is that our base units are in hours. So if we put that in minutes, all the base of this simulation will be in minutes. When we put play, there you have the simulation, how the customers arrive to ask the food, and they go and they put in each table according to their distribution. Here are the paths that they follow, and this is what you do with roads. But here is one thing that we can add to make it see better the simulation. That is, when these customers they go to the tables, you don't know if that table is busy or they have, or there's somebody. So to make that visualize, we will put a stop. We stop the module, and we are going to this option here. With this option, we can identify if a process is busy, is ideal, is inactive, or is fail. What we want to see in this simulation if that table is busy. So the only thing that we need to do is, we're gonna delete the ideal, the inactive, and the fail, because this things we don't need. We just need the busy. How you know it is busy? You have here different image that can show you that. So one that we can put is a person, or these colors here. So we will choose the colors. So if it's red, that means that the table is busy. If it's not, so will be nothing there. So for do that, we click the image that we want. We click the image that we want and we pass through this. And here in identifier, you identify to like the table that you want to see. So in this case, we will put table 1. So we are gonna to save this. Oh yeah, it's because we have the other model open. So this is our model, our current model. This is our other model open. We will close it. So we will save it. We just put it 1. So it's safe. And we just put it OK. And we will locate this over the table. We will make it bigger. So when you see this point there, that means that this table is busy. You can copy this with Ctrl C and paste it with Ctrl V to all the stations, all the tables that we want this like this sign to tell us in which state is this process. Now what you need to do is you click double time over the icon and you just need to change that to the table that you are using it. You just need to link the icon with the table. So now we're doing that. This is table 5 and the last one is table 6. So now when we simulate our process, here comes the entities, they stay here. When they order, they go through the path and they stay in this table, and you see here the red point. That means that this table is full. So as you see, it goes to the other one. And this is how like our process will behaves. Now this customer leaves, they finish to it, and they just leave the system. We want to see a little bit faster when all the tables are full, and you will see how the customers, they just leave. I don't know if you see that, but the customers, when they come here and they see the full tables, they just leave the system. So this is how you use station and route. A station to translate them from this point to the point of ask for food or just to leave the system. The road is the way that they go. This is the path, this is the road that they follow to come here. So I hope this video will help you to this course, and thank you so much for your time.